For the first video, we're going to look at how to drive this stepper motor. You're going to need a stepper motor, driver, big fat cat, some wires. You only need about 5 of them, but I'd recommend getting this kit if you're going to do the whole video series. You're going to need this microcontroller and a USB cable to connect it to your computer. And you're going to want a power supply of some kind. Anything will work, but something like this is really nice because you can limit the current and you might save yourself blowing things up. Step 1, we're going to hook up the power to the power terminals of the stepper driver. Now if it says AC, it doesn't matter which wire, black or red, goes on either AC terminal. This can take AC power. If it says plus minus, red is plus, black is minus. Now one little tip, you can put these little wires right into these holes and tighten them down. If you want to build higher quality electronics, you're going to get this thing called a ferrule. That ferrule goes on the end of the wire. Then you use this crimper to crimp that down. You're going to get a much longer lasting connection. Beautiful. When it comes to connecting these power wires, these little terminal blocks work like an elevator. You turn the screw and this elevator moves up and pinches the wire in place. So I install the cables and then snug the elevator up, tightening the screw. Make sure the elevator is all the way down before you insert the cable and then start screwing. It's not as hard as I'm making it look. There you go, get it nice and tight. Hey, if you like this screwdriver, not a sponsor, but Commando makes this. They're made in America. I've had this screwdriver for a decade, and I still have all the bits. The bits are stored in the end. This thing is awesome. Made in the USA, awesome product, awesome name. Not a sponsor, don't care if they ever are, but if you want a little screwdriver, get this thing. All right, now we're gonna connect up the pulse, direction, and enable pins. We don't need to worry about these two. So the pulse pin is like the steps. It's how many little tiny motions your motor's gonna make. I'll do an embarrassing little skit to explain this. Direction is what direction your motor's gonna spin. And enable just means allow the motor to spin. Kind of like an emergency shutoff. So let's get this wired up. What we need to do is connect all of the minus pins together, and we need to connect enable plus to enable minus. This will look a little more clear if I put a schematic up, but I'm going to do that wiring and show you what it looks like. So to connect all these minus pins, we're going to need a little monstrosity like this that's got 4 male ends and 1 female end. Now that female end will go onto that male pin on the microprocessor, and then those 4 male pins will go into all these minus positions. So we can either put a ferrule on there and crimp it, or we can take that to the solder bench and solder it. And we might as well go to the solder bench because we need to solder all these pins that didn't get soldered in the first video. If you missed the first video, it's out there. It's a gem. Okay, if you're doubting the quality of the nail soldering, that's one of the ones I did. I did another one as a practice before I made the video, and that's the other one. These are bad solder joints, but I guarantee they'll work. Like with a little practice, I think you could get this method to work, especially if you had a blowtorch or something. So there you go. All right, we're not going to do any fancy soldering on this series, so pretty much any soldering iron will work. You know, you get what you pay for. And I'll make a recommendation for the high dollar, well actually it's a low dollar one in the big realm of things, but it's a high dollar for me, soldering iron. So I'll link to that, and then I'll link to the minimum possible one you can get. You're gonna make a little mess on whatever you're soldering on, or you can get some clips and be neat about it. My point is, don't freak out about this. It's pretty easy. So you can see the soldering joints we did with a nail. I could clean those up, but screw it. Yeah, I'm just gonna solder. I'm not gonna talk about it. I'm not gonna really over explain this. You want to just put your tip on the pin, and the idea is heat up what you're going to solder, and then touch your solder to it. There. So touch what you want to solder, give it a second to heat up, and then touch your solder to it. And you don't want to blow on it. You want to let it cool down naturally. If you blow on it, you can cause the solder to be a little brittle. Kind of like quenching a knife edge, you know. You want this soft. You don't want to quench it. You want it to cool down slowly. Let's see. Yeah, you get a little rhythm, and if you tape your project down, it's a little easier. Just a little double-sided tape or just a clamp or something makes this go a lot easier. I don't know why I didn't do that. What you want to avoid is little bridges. If you get a bridge, just kind of brush that bridge away with the tip. Oops, I wasn't looking at the camera. Kind of makes me cross-eyed. Okay. And this should just give you an idea of the pace that you do this at. And, you know, man, I made another bridge. You can watch a million videos out there about people who know how to solder. I've soldered some pretty cool stuff in my life, and it all worked, you know. It's not the critic who counts, the man in the arena. So just get out there and do shit. Now, if you're an old fuck like me, this thing's called a loop. It's for looking at jewelry and stuff, and you can kind of use it to, this is not going to line up. You can use this thing to kind of inspect your solder joints, make sure there's no bridges or anything. But that's about all you need to know. Make sure there's no little solder balls or little goops in there that are going to cause you problems. You don't want the wires to touch. And again, here's the one we did with the nail. Here's the more professional or more expensively done solder joints. So remember, no excuses. The solder station I use is called a Hacko. I'll put a link. I think it costs about 150, maybe 200 bucks. Most of my life, I've used like a $30 soldering iron. So this was just a little treat to myself. All right, we soldered these wires together. You know, don't be proud. Use the handyman's secret weapon. And making a good wiring harness is a skill. This is not a good wiring harness. Maybe we'll do another video on that skill, because if you're gonna build a rugged, robust system, you can't build them like this. I'll show you good ways to build them the best I know how. This is not it. And this will cause failures. Building a wire harness is just as important of a skill as good machining, good welding, good soldering, writing good code, designing good circuit boards. Harnesses are just as important as every other part of the system. Okay, all we've done is connected enable minus, enable plus, direction minus, and pulse minus all to the same point, and that's going to be our ground that goes back to the microcontroller. Okay, and I just went ahead and connected pulse or step and pulse are the same thing, to blue, and I connected direction to white. Right, now our stepper motor is wired up. We have plus and minus pins, which we'll be connecting to this power supply, and we have ground, pulse or step, and direction, and those are going back to our microcontroller. Green, ground, goes to ground. I've hooked blue, which is pulse or step, up to 7, and I've hooked direction up to 8. Your stepper motor has 4 wires coming from it, and the colors on them are most likely going to be black, green, red, blue. That's why you should buy the one I link below. Just make it easy on yourself to start with. So you need to connect those to black goes to A+, green goes to A-, red goes to B+, blue goes to B-. And you can Google that on the internet. Just look up like stepper motor wire colors. You might have a stepper motor with different colors and you'll have to figure out something else. But this is pretty common, so don't forget to connect your stepper motor. Okay, now we're gonna plug in the USB cable. One little note here, the other end of the cable's plugged in. We should hear a toot 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 when we plug this in. There we go. Get yourself to www.arduino.cc. I think they're Italian. You want to go to software and you want to get the Arduino IDE, and it doesn't really matter what version. Most of these versions are going to work. I'm on Windows. I hope you are too, because I'm not doing this for everyone. If you're on Linux, you're smart enough to figure this out. So we're just going to go to the Windows 10. You can contribute. I'm just going to download right now. Let me enter my email. Okay, it's going to ask you to download and then put it somewhere. You can really put it anywhere. I put it in a folder called Learnin, and then just go save. All right, that should be all you need here. Okay, so you fired up the Arduino IDE and you're looking at a screen a lot like this. So what you need to do now is think about this space as your workshop. And your workshop it has a lot of tools in it, but kind of the basics. We need to go out and get a tool that is specific to driving stepper motors. So we're going to go up to Tools. We're going to go to Manage Libraries. This is where you can go out and find a bunch of free tools made by incredible people who just built them for you. And this library manager is very slow. So the key here is patience. You can see it's updating the list. We're going to type in stepper Excel, and it's updating a lot slower than I'm typing. And give it time. Don't do extra clicks, just type in stepper Excel. You could actually probably type in AccelStepper. That would be better. I have the latest version, but it's going to give you the option to install or to update. And what you want to do is just click install and then close out of this. So once you've closed out of that, you're going to go ahead and go to File, Examples, and there's a ton of examples. So just kind of browse through these. Blinking, analog reading, all of these are interesting. And I have a bunch of extra examples that you probably won't have because I've installed a lot of different tools into my workshop. So your workshop might be a little more empty because you just started it. But this just kind of also helps explain that you can load your workshop up with a bunch of cool stuff. So we're going to go to AccelStepper constant speed and open that up. Okay, so your version probably looks like this when you open it. But what you need to do to make this work is you need to add this to your file. And I will put that in the description. You just need to copy it and paste it, and then put these two slashes in front of what was there. And those slashes are comments. So I can just add a comment like, deplorables are cool. And that doesn't matter to how the stepper motor runs. It's just a comment for humans to read. But what we did here is I added these two lines, and what it's doing is it's declaring a element called stepper So the tool, AccelStepper, is declaring a new element, and it's saying, I want to make this new thing called stepper. We could call this stepper cat, but we just call it stepper. And it's AccelStepper, so what tool, and then it's calling it a driver, and it's saying 7/8. So 7/8 stand for step direction. And you'll recognize that we put the step or pulse pin on pin 7 and pin 8. So this is declaring what the tool is called, and what pins the tool is going to use. What they had as a default was kind of a more sorry, I've been drinking a more complicated form of this tool, but we are simplifying this tool so it just uses a step and direction. And now down here, we're going to go through a setup phase. Don't worry about this too much. We're just kind of setting up our stepper tool. And it's just like any tool in your garage. Before you use your table saw, you kind of set up an angle and a distance from your guard. We're setting a max speed, and we'll set a set speed. And the max speed is just kind of a safety, and we'll do a set speed. And then we'll go into the main loop, and the controller basically comes through and says, hey, we're going to include this new tool you just installed, AccelStepper. We're going to set up our tool and tell it which pins it can use, kind of communicate to the tool how we did the wiring. We're going to tell the tool what the safety limits are, and then we're going to tell it what speed we want to run at. And then we have the simplest program in the world. It just says, stepper, run speed. And it just does this forever. Run speed, run speed, run speed. So let's do one more step of setting up our power supply to power on the stepper motor, and then we will download this code onto the microcontroller, and we will watch the stepper run. Okay, just a little recap. We have our stepper motor connected to our stepper driver. That is connected to our little microcontroller, which is connected to our computer. And this code is configuring that microcontroller to tell the stepper driver how to run the stepper motor, but we need to power it. We're going to take a little bit of time here to teach you one more skill, which is how to use this power supply effectively. And this is a really good tool because it has voltage and current. Think of a water tank. Voltage is how much water is in your water tank, and current is the rate that the water can flow out of there. So what we've done is we've shorted this power supply out, and we're gonna increase the voltage, and you notice the voltage doesn't go up, but the current goes up. So we have 2.7 amps short circuited. That means the flow of current is just running in here. And we're gonna watch how these knobs work. So we're gonna decrease that current. There's a coarse and a fine. I'll increase the fine, increase the coarse. And so you see how this power supply can act as more of a current source, just flowing current, short-circuited. And of course, when we open that up, okay, I can't open it with one hand. But next we'll open that up. But what we want to do here is limit our current so that in the worst case, the most amount that can flow out of this tank, let's give it 2 amps. That shouldn't burn anything up. We'll use the fine adjust, set that to 2 amps. So you can use your fine and coarse current adjustment. With this shorted, that won't hurt your power supply, so don't worry about that. And now we'll adjust the voltage. Okay, so I've unclipped the leads, and now you can see I can actually control the voltage, and this stepper motor driver I have uses about 40 volts. It can actually go up to like 100. We're gonna use 40. So we have 40 volts at 2 amps. 40 volts times 2 amps is 80 watts. That should be more than enough to drive our stepper. So what I'm gonna do now that this is set is, I could do this one of two ways. I can just hook up the wires here, and if I were to short them, there might be a little spark, but it's just gonna hit your current limit. Sorry, it will make sparks, but it won't probably hurt anything. And yeah, now we have powered up our stepper driver, and I get a little squirrely with this stuff. I'm probably a little too comfortable. So now what we want to do is we have our code. Man, I apologize for the blurriness. What we want to do is hit upload, and our code is going to compile. This means this entire tool shop is saying, did the stuff you write here work for this tool? And now it's uploading, and you'll see some lights blinking on this board, and then you'll see it say done uploading, and your stepper motor should be spinning. So let's change that speed a little bit. Let's change it down to 500, and we'll hit upload, and we'll see it compiling. And I'm just going to zoom out here so you can kind of watch what happens. So it just uploaded the code, and it's going to restart now, and see how slow that is spinning. Okay, let's give it 10,000 RPM. So we're going to do the same thing, hit upload, and the code's still running. You'll hear the boop boop boop. So it's uploading the new code. Now it's going to start up. Now we're spinning. And let's just play around. We can't really hurt much here. Let's try 100,000. I have no idea what, like, I'm doing this live. So we're uploading. We're using about 15 watts to go this speed. Okay, now it's gonna start again. Spinning a little faster. We're drawing about 16 watts. So that's about as fast as we can go. Next video, God, I so apologize for the focus. Okay, next week we are going to play around with the switches that control the number of pulses per revolution. So we'll be able to get this thing to spin faster, and we'll be able to increase the current. So stay tuned, and we'll do a little deeper dive into stepper motor control.